So here we're looking at continuing our explanation of differentiation. And now we're going to look at differentiating expressions which have fractional indices in them. So how do we actually go through about those using our knowledge of indices that we're and square root symbols and things like that, how we can use those and differentiate those sorts of functions. Okay, so I'm going to go through these step by step, and you guys should sort of hopefully get a good idea on that one. So first one, we've got y is equal to 7x, and what they've written it as is they've actually written it as an as a mixed fraction here. So it's 2.5. I'm just going to rewrite that as an improper fraction, right? Which becomes 5/2 as an improper fraction, just to make it a little bit easier. Now again, we're going to follow the same rules as we have before. So we note that if we've got ax to the power of n, the derivative of that is going to be na, and then x to the power of n minus 1. Okay, so essentially the power comes to the front, and we subtract 1 from the power. So we're going to do the same thing here. Okay, we're going to bring the power to the front. That becomes 7 times 5/2, and then we're going to subtract the power by 1. So 5/2 minus 1. And now this becomes 35/2x. You can write it as a decimal as well. And then 5/2 minus 1 becomes 3/2. Okay, so I'm just going to write it as a fraction just like that. So I'm just going to write that as 17.5x and then 3/2. And then sometimes what they're also asking is they'll also require you that your solution should not have any fractional indices. All your answers should be in insert form, something like what they've done here. So to do that, it's very simple, right? We look at the numerator and we look at the denominator. This denominator, that's going to tell us what sort of root it is, right? If it's 2, it's just a normal square root, which you would just write like this. But say this denominator was 3 or 4 or 5, you would have 3 or 4 or 5 on this outside portion over here. Okay, but we don't have anything. It's just 2, so we don't have to write that. And the numerator, that tells us what the power inside the square root is going to be. So this will be x to the power of 3. Okay, so the numerator tells us what type of root is going to be. Is it square root or cube root, so on and so forth. And the numerator tells us what the power is going to be. So the answer of this, I'm just going to rewrite this, is 17.5 square root x to the power of 3. Okay, so that's our solution for this first one here. So it's the same rules as we've learned this before. We're doing the same thing. We're just applying this now to fractions, and just there's a little bit more work involved into getting into the fraction form and converting into the third form. Okay, now second question. Now we've got insert form already. So what we're going to have to do is we're going to have to first convert it into fractional form, into fractional indices form, so we can derive it. And then once we've done that, then we can convert it back into our third form. So fx is equal to, so this is what I was talking about earlier. So see over here now we've got 3 on the outside and we've got 2 on the inside. So if you rewrite this as a fraction, that means we're going to have 2 on the numerator and 3 on the denominator. Okay, and now we can, I should have written this over here, derive a dx. And now we're going to follow the same rule over here. Okay, so we're going to bring the power down, and then we're going to subtract the power by 1. So f dash of x is equal to, so we bring the power down, so 2/3x, and then you reduce the power by 1, so 2/3 minus 1. Okay, so that just becomes 2/3x, and now 2/3 minus 1 is just -1/3. Now again, we've got a fractional indices here, which we don't want. We also don't like having negative indices, so we're going to, again, convert that back. So the first thing we're going to do is we're going to bring this to the denominator, so it becomes a positive indice. So we have 2/3x to the power of 1/3. And then we can convert this into third form. So we have 2 and then 3. Then as I said, we've got a 3 in the denominator, so it's a cube root. And then there's a 1 in the numerator, so it's just x. There's no power associated with that. So that means that the derivative of fx in this case is 2 over 3 times cube root x. Okay, going on to the next question. We have f of x is equal to negative 10x to the power negative 0.7. So we have no fractions there, we just have decimals, but it's going to be a similar concept. So I'm just going to write this question down again. Over here, well, I could just zoom out a little bit. Still going to have to write it down. Okay. Who's negative 10x to the power negative 0.7. So again, we're going to follow that same rule that I've written above. So f dash of x is equal to negative 10, and we're going to bring the power down, so times negative 0.7. And then we're going to subtract the power by 1. So negative 0.7 minus 1. Okay, so rewriting that and simplifying, negative 10 times negative 0.7 is just 7. 7x to the power of negative 0.3. And again, we don't want negative indices, so we're going to bring that to the bottom. And that's going to become 7 x to the power of 0.3, or x to the power of, oops, sorry, I made a mistake here. No. This is not negative 0.3. Negative 0.7 minus 1 is negative 1.7. Apologies for that. Let's go ahead and fix that now. Okay. And that's x to the power of negative. And so now, since it's already, it's going to be hard to write this as a root. It's going to be messy anyway, so we can just leave it like this. And then we'll do d on this side over here. So d looks a bit tricky, but there's actually a way you can simplify this. So you can see all the terms in the numerator, they have an x in them. So all we can do is, since the denominator is just x, we can just simplify this fraction. Now we can split this fraction up. So you can say this is 3x over x minus 3x root x over x minus 9x squared over x. And now again, take out x on all of these. So 3x over x, it's just 3. So this is not y. So y is equal to 3. Again, x over x cancels out. So 3 minus 3 root x. And then x squared and x cancels up. So then we have minus 9x. Okay, now this is a much simpler equation for us to do with. One more thing I'll do is I'll just change this square root into fractional indices so that we can derive it straight away. So we've got y is equal to 3 minus 3x to the power of half minus 9x. Okay, now we're able to derive this. So write dy over dx. So as 3 is just a constant, so a big derivative of that is just 0, so that just goes away. Now for this negative 3x to the power of half, again, we're going to follow the same rule here. So we're going to do negative 3 times half. We're going to bring the power down. I'm just doing it in brackets just so it's good to understand. And then we subtract the power by 1. And then the derivative of 9x just becomes 9. Okay. Now if you simplify this, so negative 3 times half is just negative 3 over 2. And we've got half minus 1 is negative half. Okay, so again, simplifying that, this will just be negative 3 over 2 root x minus 9. So since there was a negative half, what I did, I just put the x on the denominator, and I just converted the half to square root, back into square root form. So the derivative would be negative 3 over 2 root x minus 9. Okay. And then last question, we've got y is equal to 4 over x root x. So again, I'm going to just write x root x as x to the power of half. So I'm just going to do it's x times the power of half. Now what we've got, this is equal to 4 over Now we've got two lot of multiplication here. We've got x times x to the power 5. And we know that when we're multiplying these sorts of things, when we're multiplying indices which have the same base, we add the indices together, right? So there's just an imaginary one here. So this becomes 1 plus half, which is 3 over 2. Okay, now to actually derive this, what we're going to do is we're going to bring this x up to the top. And to do that, nothing changes, just the indices becomes negative. Okay, and now we can derive this. So we've got dy over dx is equal to, again, bringing the power down, 4 times negative 3 over 2, and then reducing the power by 1. So negative 3 over 2 minus 1. So 4 times negative 3 over 2 is just negative 12 over 2, which is negative 6x. And then minus 3 over 2 minus 1. That becomes minus 5 over 2. And then again, to get rid of the negative, we'll bring that back down onto the bottom. Negative 6x, and then 5 over 2. Yeah, we can actually put this into into root form. So that's again negative 6. Now, as I said, the denominator is what goes outside, and the numerator, and the numerator is what goes inside. So the denominator is 2, so it's just a normal square root, and the power is x to the power 5. Now, that is a numerator. So dy over dx is this. So nothing really new when we talk about fractional indices, just a few more steps. We usually don't like keeping them. We usually don't like having negative indices personally. We also don't like having fractional indices as well. So try to convert it into root form where you can, unless it's too complicated, like something like this. Then you can leave it as decimal form or fraction form.